Hello everyone, my name is Chuhan. On behalf of my co-authors, I'm pleased to present our paper, NL2Color, Refining Color Palettes for Charts with Natural Language. The choice of color is a crucial aspect of chart design as it greatly contributes to the aesthetics, engagement, and memorability of charts. In practice, users often need to refine the color palettes of their charts to align with various factors. For example, users may not be satisfied with the initial color palettes they design and hope to improve the palettes. Also, if users wish to apply their previously created charts in a slide deck with a certain template, they need to modify the chart's color palettes to match the template. Unfortunately, users' requests for refining color palettes are often vague and abstract. Changing color palettes to meet such requirements is challenging, particularly for novice users in chart design. First, novices struggle to translate abstract refinement needs into specific color editing actions, since they lack the necessary domain knowledge to identify the colors that could achieve their desired effects. Moreover, they may be uncertain about the details of their requests, such as how to select colors that complement the primary color of the slide deck. While many tools have been developed to aid in color palette selection, users may find it tedious to locate the appropriate palette among a large number of options. Even though they can find the right one, they may also struggle with mapping colors in the new palette to elements in the chart. To make visualization authoring and modification more accessible, various natural language-based visualization authoring tools have emerged. However, these tools primarily focus on concrete natural language editing requests. When users just have vague or abstract requests, they still need to translate the requests into executable low-level editing actions before employing these tools. So in this paper, we propose a tool, NL2Color, that allows novice users to refine the color palettes of charts by expressing their vague or abstract requests in natural language. We conducted semi-structured interviews with 6 novices. We asked them about the vague or abstract requests they have when refining color palettes, the difficulties they face during the refinement process, as well as their expectations and concerns for the services supporting color palette refinement. Based on the interview results, we identified 2 common types of refinement requests. The first is descriptive word-based requests, where participants utilize descriptive words or phrases to specify their desired color palettes. Such requests could be further divided into those with detailed references and those without. For without reference requests, participants only express their vague feelings about the original charts, such as desired styles and changing their directions, but they could not imagine what kind of color palettes can achieve their desired outcomes. With the same without reference requests, participants may desire different refinements in different usage scenarios, as a brand new or fine-tuned color palettes. If the original palettes largely meet their needs, they just need a fine-tuning to the palettes, which means that the hues of the colors in the original palettes do not need to be revised, but only other small changes are required. In other cases, participants desire a brand new color palettes. As for without reference requests, participants may remember a reference chart in their minds but cannot find it. Therefore, they can only describe the reference in natural language. When having such requests, the participants sought to gain a brand new set of color palettes. The second type of refinement request is chart topic based, where participants hope to make the chart's color palettes align with specific topics. When refining color palettes, Participants request that the direction of the color scales embedded in the original palettes should be preserved in the refined palettes. For example, if some components of a chart are denoted by sequential or divergent colors, the revised color palettes should also contain corresponding sequential or divergent colors to represent these components. However, they were concerned that it is challenging to identify complex color scales. Even though such color scales can be identified properly, a tedious and time-consuming manual color mapping is commonly required because the consistency of the direction of the color scales between refined palettes and original ones is rarely satisfied. Based on these results, we concluded 3 design requirements for our system design and developed our system, NL2Color. The implementation of NL2Color, including data collection and a pipeline that automatically refine chart color palettes based on users' requests. The data in our dataset were collected through 2 methods. First, we invited 8 novices and asked them to write down vague or abstract requests they may make in their day-to-day life. Then we collected 60 SVG-based charts from the Plotly Chart Studio and asked the novices to match the requests they provided to each chart. Since we found that each chart corresponded to at least 4 requests, we randomly selected 2 matched requests for each chart. As the other method to collect data, we asked the participants in the formative study to provide the charts they mentioned in the interview that they were not satisfied with and their corresponding refinement requests. We then invited 9 design experts to design a new color palette for each chart based on the refinement request and finalized our dataset of 131 triplets of an original color palette, a vague or abstract request, and a new color palette designed by human experts. Then we developed a pipeline that refines the color palette of the input chart based on the user's refinement requests. The pipeline consists of 2 modules. The original color palette extraction module automatically extracts the color palette of user-uploaded chart. It first extracted all the unique colors in the chart and identified all sets of sequential colors and divergent colors in them. Then we identified the primary colors of each set of sequential and divergent colors and combined them with the remaining categorical colors as our extracted original color palette. The color palette refinement module employed GPT-3 to refine the original chart color palettes based on users' requests. Specifically, we crafted 2 few-shot prompts respectively for the brand new and fine-tuned refinement requests. In each prompt, we first described our color palette refinement task and then identified 5 triplets in our dataset whose requests have the highest similarity with the input request as few-shot examples. After GPT-3 returned the refined color palettes, we extended the new primary colors in them into new sequential or divergent colors based on the original ones so that we could preserve the color scales in the original palettes. Here are some examples of color palette refined by NL2Color. These examples show that NL2Color can handle the different types of color palette refinement requests. To assess the effectiveness and usefulness of NL2Color, we conducted a 2-stage evaluation. First, we evaluated how well NL2Color refines color palettes from the perspective of chart readers in a crowdsourcing study. Since we designed 2 models respectively for the fine-tuned and brand new requests, we evaluated their performance separately. For each model, we compared the quality of the new color palettes refined by NL2Color with those designed by human experts. Also, to validate our prompt design, we further crafted 2 zero-shot prompts for GPT-3 model, which only contain task descriptions and compared NL2Color refined color palettes with zero shot model refined ones. The results prove that the color palettes refined by NL2Color have no significantly large difference from those designed by human experts, and the prompts we designed for NL2Color are effective in facilitating the GPT-3 model to handle the color palette refinement tasks. To evaluate NL2Color with real users and explore its influence on users' color palette refinement process, we then conducted a within-subject user study. In the control condition, the participants are allowed to use any tools and websites they commonly use in their routine practices to revise the color palettes, while participants were allowed to use NL2Color only in the experiment condition. By analyzing the quantitative measures, we found that compared with the control condition, participants in the experiment condition reported faster color palette refinement and expressed higher confidence in their final refined color palettes. In addition, they perceived lower cognitive load during the palette refinement tasks. The qualitative feedback shows that participants generally have positive responses to the usability and usefulness of NL2Color. They not only regarded the system as satisfactory, convenient, intuitive, and user-friendly, but also praised the inspiration of the system. For more details, please check our paper. Thanks for your listening and welcome questions.